Samuel Singer here, the founder and executive director of Wyoming Stargazing. Thanks for joining me. Today is really Mind Bending Astronomy because we're going to be talking about the bending of space-time. Last time we explored Einstein's famous equation E equals mc squared. We learned that it tells us that mass is basically the amount of energy that something contains. We also unraveled the typical definition of mass, that it's the amount of stuff or material in an object, and revealed that mass is an emergent property that's caused by the confinement of other particles. Now that we've examined mass, as well as the nature of light before that, we're ready to tackle the theories of special and general relativity. We'll start with general relativity because we can sum up the entire theory in just one sentence. Mass tells space-time how to curve, and space-time tells mass how to move. That's it. That's all you really need to know to understand the general theory of relativity. Anything that has mass, even massless photons inside a box, causes a curvature, a bending in space-time around it, like a bowling ball rolling on a mattress. In that analogy, the mattress is space-time, and the bowling ball is a star over the mattress. The curvature created by mass causes other objects with mass to change their direction of travel when they encounter the curvature. Imagine a marble rolling around a really big funnel. In this case, the marble descends downwards to the bottom of the funnel because of Earth's gravity, and because as it moves, friction slows the marble down. Far away from Earth and out in space, there's no friction. So the marble keeps going around and around and around, just like planets orbit stars and how moons orbit planets. That's gravity. The curvature caused by mass that creates, among other things, curved paths around objects we call orbits. Forget Newton's law of universal gravitation. That's just a math equation that describes the force of gravity. The curvature of space-time is what causes gravity. Okay, so now on to special relativity. Here is where Einstein connected the idea of causality with light. Einstein knew that the speed of light was the fastest speed possible, the speed of causality. So he wondered what would happen if observers traveling at radically different speeds, even close to the speed of light, observed the same phenomena. You can't just add their speeds to the speed of light. That's impossible. What came out of these thought experiments is called the special theory of relativity. It shows us that two observers moving at different speeds, one close to the speed of light, experience the timing of an event in totally different ways. The only way to reconcile their observations is by using either the Lorentz transformations or the space-time interval in a more general sense. Special relativity destroys the idea of simultaneity, that an event actually happened at a fixed time that everyone agrees upon. Time becomes malleable, just like the curvature of space-time described by general relativity. And in fact, special relativity is just a special case of general relativity when things are moving close or at the speed of light. To hear more about these theories, check out the videos that I have in the transcripts of these talks. And yes, one of the videos is of The Late Show with Stephen Colbert, but his guest is Brian Greene, who's probably one of the most brilliant physicists and science writers alive. Next time, we're going to explore some of the other crazy consequences of the curvature and bending of space. Until then, be well, and don't forget to look up.